Okay, today I want to talk a little bit about what happens if we have powers that are either a 1 or a 0, or they could be negative. So I want you to look at a little chart that I have at the top of the page. I've got 3 cubed equals 27, 3 squared equals 9, 3 to the 1 equals 3. So I like to look for patterns. And you can see on the left side I've just counted down by exponents 3, 2, 1. So can you figure out what a pattern is to get from 27 to 9, 9 to 3? I'll let you look at it for a second and see. Well, the pattern is I'm dividing by 3 each time. 27 divided by 3 is 9. 9 divided by 3 is 3. So if I want to continue that pattern, on the left side, 3 to the 0 would be the next number. 3, 2, 1, 0. So if I continue the pattern on the right side of the equal sign, if I take 3 divided by 3, I get a 1. And that is the rule that we're about to talk about. 3 to the 0 equals 1. That doesn't sound like it should be right, but it is correct. If you have any term raised to the 0 power, that equals the number 1. So again, if we try to do it, let's do 4 cubed. 4 cubed is 64. 4 squared is 16. 4 to the 1 is 4. Well, and what you're ending up doing is dividing by the base. 64 divided by 4 is 16. 16 divided by 4 is 4. So if I go down here to 4 to the 0, 4 divided by 4 is a 1 again. I have to write 4. So it's the same pattern. You get a 1 each time when you get to the 0 power. Alright, so let's look at some examples. 5 to the 0 power is equal to 1. Negative 5 in parentheses. In the last section we talked about having parentheses, and anything in the parentheses is raised to the power that's on the outside of the parentheses. So the negative is raised as well. So anything raised to the 0 power equals 1. Now, the difference between these two are the parentheses. Parentheses matter. We've talked in previous chapters about how if you have a negative outside of parentheses, it carries to your answer. So what this is saying is the opposite of 5 to the 0 power. Well, 5 to the 0 power is equal to 1. The opposite of that is negative 1. So the negative will carry to this one, and you will get a negative 1. Alright, so don't let yourself get tricked. Here's another example. Negative 6x to the 0 power. In this one, there are no parentheses, so the only base that's getting the 0 power is the x. The negative 6 is not affected at all. So it's negative 6, x to the 0 is a 1, so this would simplify to negative 6. Now, big difference if you have parentheses around that negative 6x. In this case, both the negative 6 and the x are getting the 0 power, and guess what they equal? A 1. Not very intuitive, but that's how it goes, because remember our pattern that we did. So any non-zero real number raised to the 0 power is equal to 1. So again, they explained the difference between parentheses and no parentheses in their example. Let's do one more. Negative 4 to the 0 power, the negative carries. 4 to the 0 power is equal to 1. Negative 4 in parentheses to the 0 power is equal to a 1. Don't be fooled. Now, we need to think about negative exponents. So, I'm just going to carry over. Remember, I had 3 squared was 9, 3 to the 1 was 3, and we just figured out that 3 to the 0 is equal to 1. Remember, my pattern was I was dividing by 3 each time. So if I continue the pattern, if I go down one more, I'm going to have 3 to the negative 1. Now I'm hitting negative numbers. Well, 1 divided by 3, I'm going to write it as a fraction, is 1/3. The power on the 1 and 1/3 is a 1, and the power on the 3 in the bottom is a 1. Let's do one more. 3 to the negative 2. So if I were to divide 1/3 divided by 3, I'm going to come up over here and say 1/3 divided by 3 over 1. So that's keep, change, flip. 1/3 times 1/3 is 1/9. I'm not going to write the 9 as a 9. I'm going to write it as a power of 3. 3 squared. And you see a pattern here. You see I have a negative 1 here in the numerator, but when I simplified it, it became a positive 1 with the 3 in the denominator. 3 to the negative 2, I have a negative when it's in the numerator. When I moved it down here and brought it to the denominator, it became a positive. So b to the negative n simplifies to 1 over b to the n. If you have a negative exponent in the numerator, you move the base to the denominator and make the exponent positive. If you had a negative exponent in the denominator of a fraction with the base, move that base up to the numerator and you can change its exponent to positive. So it's kind of like, I think of it as being happy and unhappy. If you're unhappy, you have a negative exponent, you move downstairs, you become happy. Positive exponent. If you are downstairs and you have a negative exponent, you can move upstairs and become happy and have a positive exponent. So x to the negative 5 would be written as 1 over x to the 5th. 4 to the negative 1 would be 1 over 4 to the 1, which is equal to 1/4. Negative 2 to the negative 4 power. That negative 2 is in parentheses, so that comes, the negative in front of that 2 comes with it. It's the exponent that becomes positive. And so now we can work that out. Negative 2 times negative 2 times negative 2 times negative 2 should give me positive 16. Okay, so you try some. Z to the negative 3, 1 over z cubed. Alright, so here's some where we have some fractions. And again, I like to use my power rule first, so I'll simplify these. So anything in the parentheses is getting the power. So 1 to the negative 2, 5 to the negative 2. Now, neither one of these bases are happy. They need to move. So the 5 to the negative 2 is going to come to the top and become 5 squared. The 1 to the negative 2 comes to the bottom and becomes 1 squared. Well, 1 squared is just 1, so I really just have 5 squared, which would be 25. Okay, here's another one. Negative 4/3, so that's going to be negative 4. I'm going to keep the negative with the 4. To the negative 3 power, and then 3 to the negative 3 power. Each of those got that negative exponent, so I'm going to move the 3 to the top. It's going to become 3 cubed. On the bottom, the negative still stays with that 4, but the cubed part becomes positive. So 3 cubed is 27. 4 cubed is going to be 64, and it's going to stay negative because I've got an odd number of negatives, so I have a negative answer. Alright, so here's an example. This time I just have p to the negative 4. I don't have anything on the numerator that really has to go anywhere. P to the negative 4 is not happy, so it's going to come to the top and be a p to the 4th. You can put the 1 in front of it if you want to. If that had been a 2, I'd have a 2p to the 4th, but since it's a 1, I don't have to write it. X to the negative 3, 1 over x cubed. Alright, so try some of these. 3 to the negative 3 over 4. 3 over 4 to the negative 3, so 3 to the negative 3. 4 to the negative 3. So neither one of them are happy, so 4 to the third comes to the top, 3 to the third goes to the bottom. So I have 64 over 27. Now in this next one, the 3 doesn't have anything negative exponent wise with it, so he's going to stay just where he is. The m to the negative 3 needs to come. So the 3 stays on top, the m cubed comes up with it. Okay, let's do these parentheses because it seems like parentheses is always going to be confusing. So if I have parentheses, remember, both things in that parentheses get the exponent. So both the 4c are going to come to the denominator and become squared. Now, if you move everything in the whole term to the denominator, you can't just leave the numerator blank. So we put a placement of 1 at the top. Okay? So then we could work this out. 1 over 4 squared is going to be 16, and then c squared is just c squared. Okay, in this next one, the 4 is not, there's no parentheses here. So the only term that's getting, the only base that's getting the -2 is the c. So 4 stays put. The c needs to go to the denominator and become c squared. Same thing for this next one. There is no parentheses, so the -4, it is negative, but it's negative out front. He doesn't have a negative exponent with him. The c is what has the negative exponent, so it moves to the denominator and becomes c squared. Okay? Everybody doing all right with these? Let's do a couple more. 3z to the -3, so that's going to be 3 to the -3 and a z to the -3. At the example, I just moved them both downstairs immediately, so 1 over 3z cubed. So 1 over 3 cubes, 3 times 3 times 3, which is 27. Z cubed is z cubed. In the bottom example, the 3 stays put because he does not have that exponent with him. It's the z that needs to move to the denominator and be z cubed. Not too bad. Okay, let's look at the next page. These are somewhere you'll have just write only using positive exponents. Okay. Just looking real quick. Alright, so only using positive exponents. We have -8, j to the -4, k to the -2. So this could be a combination of any of the rules that we have used so far. So I'm going to have -8 to the -2, j to the -4 times -2 is going to be +8. And then on my k, there's an imaginary 1 there. 1 times -2 is -2. So you can see j to the 8, he is positive. He's going to stay in the numerator. -8 to the -2 is going to come to the denominator and become -8 squared. K to the -2 needs to come to the denominator and become k squared. So that's going to give me j to the 8 over -8 squared is -8 times -8. So that's a +64 k squared. Okay, let's do this next one. We've got a 4 to the -3. We've got an x, that's a -12 times a -3, which is +36. And then for my y, that's a +8 times a -3, -24. So don't forget your positive and negative rules on these. Then I've got 3 to the -3. I should have put this 4 in parentheses. And then I've got x to the 8 times -3 is -24. And then y to the -3 because there's a 1 with that. Now, this one's going to look a little odd when I work this one out. And give yourself some space on these. 4 to the -3 is going to come to the bottom and become 4 cubed. We'll work it out in a minute. 3 to the -3 is unhappy. He comes to the top and becomes 3 cubed. Alright, now, if we want to, you have options. We can go ahead and move what needs to be moved. So, x to the 36 is fine right where he is. X to the -24 needs to come upstairs. So, I'm going to end up combining those in a second. We're just going to leave them alone right now. Now, with the y's, both of them were negative. So, the y to the 24 needs to come to the bottom. And the y to the -3 comes to the top, and then we will do our subtraction with that. So 3 cubed is 27. X to the 36 times x to the 24. So you need to add 36 plus 24. That's going to give me x to the 60. Got lots of x's. 4 cubed, 4 times 4 times 4 is 64. Then let's do our y's. 3 minus 24. So 3 minus 24 gives me negative 21. So my y ends up with a negative 21. So I'm not done with my final answer, because that y is negative, got to bring him downstairs. So 27x to the 60th stays on top. 64 is in the denominator, and the y now needs to come back downstairs and be a y to the 21. So sometimes they can get involved. You have to take them slowly. Okay, this next one, let's do it since these are these are long. They can be very, very long. Okay, so we've got 3x to the negative 16. So I'm going to have a 3 to the negative 2. I'm going to have an x to the negative 16 times negative 2 gives me positive 32. For my y, 4 times negative 2 is negative 8. And then in the denominator, 2 to the negative 2. X, negative 8 times negative 2 is positive 16. Y raised to the negative 2, y to the negative 2. Now, I'm going to do this one a little different, because you can, once you have all of the rules, which we have gone over all of the rules now, you can combine them or use them in whatever order you see fit. There's no set way necessarily to do these. So in the example I did above, I moved everything and then did subtraction. So on this one, I'm going to move the numbers, because I can't do anything with these bases. So I'm going to move the numbers and make this a 3 squared and make this one a 2 squared. But this time with my variables, I'm going to go ahead and do the subtraction. 32 minus 16 gives me, I believe it's going to give me 16. Yes, so I have 16. So 32 minus 16. That's what I did for the x's. Now for the y's, I have negative 8 minus a minus 2, because I subtract these two exponents, the top minus the bottom, and with the bottom one I end up with double negatives. So I'm going to use I'm going to change that to red, so that becomes plus plus. So I have negative 8 plus 2, which is negative 6. So I have y to the negative 6, which then we know that the y is going to have to then move to the denominator, because we can't leave a negative 6 in the numerator. So 2 squared is going to give me 4. There's my number on top. X to the 16, he's positive, so he stays on top. On the bottom, 3 squared is 9. And then the y needs to move down to the denominator and be y to the 6th in the denominator. So you see, on this one, I subtracted first and then moved. On the one above it, I moved them around and then did the subtraction. So you can do them either way, and you'll still get them worked out. Have a wonderful rest of your day.